All right, textbooks open to page 142. Page 142. And for homework, you did numbers 1, 3, 5, 7 through 10 on this page. And then back on page 141, had a couple of word problems, or a few word problems, numbers 8, 10, and 11 you were supposed to work. Let's go and take a look at these together. I'll go check Maddie's while you see if you can find your homework. 8, 10, 11, 1, 3, 5. Good. So neat and so organized and so easy to find exactly where you expect it to be. Pays to be organized, doesn't it, Maddie? All right, now Brecken. Oh, there, we found it. 10, 11, I'm picking on 8, 10, 11, 1, 3, 5. Good. All right. Number 1, you were supposed to write an equation in slope-intercept form. They gave you the slope, they gave you the y-intercept. Literally could not be easier, Maddie. Right, y equals 3x plus 2. Number 3, they gave you the slope, but they didn't give you the y-intercept. Rather, you had to plug in x and y and m to find b, and then get the equation. What was your equation for number 3, Brecken? Negative 3x plus 5. We knew it would be y equals negative 3x something, and we found the positive 5. Then for number 5, they didn't give you nothing. You had to find the slope. Then you also had to find the y-intercept. What did you get for the slope, first of all, Maddie? 7 over 5. You plugged that in with one of the two xy points, didn't matter which one, ended up with a y-intercept of, correct slope, not the right y-intercept. What was your, did you get the right slope, 7/5? What did you get for your y-intercept?
I got 14 over 5.
Let's take a look at this very quickly. So we got the correct slope. So we know in the form y equals mx plus b, we know this is going to be 7/5. As far as x is concerned, I've got a couple of choices. Which x value did you plug in, Maddie?
I didn't do that.
I'm sorry?
I just said y equals 7 and 5 plus 4.
Oh, okay. Yeah, so 3, 4 isn't the y-intercept though, is it? That's a random point, but it's not a y-intercept. So we should have plugged in a point. Which point? Yeah, I would plug in the 3, 4, right? Put the 4 for the y and the 3 here. I just don't like negatives, right? Negative 2, negative 3, just obnoxious. Put this over 1, and nothing's going to cancel, right, Brecken? So, did you plug in 3, 4 by any chance?
I don't think so.
Did you negative 2, negative 3?
No, I did put in 3.
Did you put the 3 for the x and the 4 for the y, or did you get them switched around backwards?
I put negative 4 on the left for the y, and then
Negative 4? There's no, not a negative 4. Yeah, I think you're looking at number 3.
maybe.
We're on number 5.
I don't know what I put in.
Well, what we should have done was plug in the 3 here, should have multiplied to get 21/5. So 4 is equal to 21/5 plus b. Could just multiply everything by a 5 to get 20 equals 21 plus 5b. Move that over to get negative 1 equals 5b. b equals negative 1/5. We already knew the m. We now know the b. Should have gotten y equals 7/5 x, negative 1/5 for our answer. Moving on to number 7. You're supposed to solve the inequality. It said to graph the solutions. We haven't been doing that, so I'm not too picky if you did or didn't. Number 7, what was your answer, Maddie? Good, x is greater than or equal to 1. If you graphed, solid dot on the 1, shade everything to positive infinity. Number 8, Brecken. Good, x is less than or equal to 1. Or you might have had 1 is greater than or equal to x. Either way, you should have put a solid dot on the 1 and shaded everything to the negative infinity side if you graphed it. Number 9, Maddie. No, Brecken? You had the same.
2.
X is greater than or equal to 2, which is not the same thing. It is the correct answer. X is greater than or equal to 2. Quickly check your work here, Maddie. 12 negative 3x positive 2 is less than or equal to x positive 6. Did you distribute correctly? Here, I would move the 3x over as a positive to get 4x, combine to get 14, and then move the 6 over as a negative 6 to get 8. So that 8 is less than or equal to 4x, so that x is greater than or equal to 2, or 2 is less than or equal to x. Did you find your mistake? Gotcha. So yeah, just be careful with that. Number 10, back to Maddie for redemption. X is less than negative 3. It would be open circle on negative 3 and then shading everything to the negative infinity side. Questions on those? All right, let's turn back to page 141. Take a look at word problems 8, 10, and 11. Go ahead and read word problem 8 for us if you would, Brecken.
Brett cuts grass for $30 per yard. How many yards would he need to cut in a day to earn at least $200?
At least $200. What does at least mean, Maddie? So what he wants to earn needs to be greater than or equal to $200. How does he earn his money? Reckon he? And the question is, how many yards of grass does he need to cut, right? How many? We don't know, so let's just call it. But we know that for every yard he cuts, he makes $30. Now this assumes he probably lives in a subdivision with cookie cutter homes and cookie cutter yards, okay? Because otherwise he probably wouldn't have one set rate for everybody. You know, big yards should be more, little yards more. But anyway, whatever. How would I show $30 per yard, Maddie? 30x. So 30x is how much he's going to earn. That needs to be greater than or equal to 200. Did we have this equation? And then, of course, we need to simply solve by the 30 away. When I do, I'm going to start by knocking off the zeros and saying, how many times does 3 go into 20, class? 6 2/3. But can you cut, well, you can cut 2/3 of a lawn. Are you going to keep the customer happy if you cut 2/3 of a lawn? So we definitely have to round. The question is, do we round up or down? Because you can't base it on what you would normally do. It's all based on the symbol. Do we round up or down, Maddie? Because he has to cut more than or equal to 6 2/3. Since you can't cut 6 2/3 lawns and actually keep a customer, we have to go more than to the next smallest number, which would be 7. So he needs to cut at least 7 lawns. Do we get at least 7 lawns for our answer? Number 10. Go and read it for us, Maddie. All right, now this actually, I worked at the bookstore warehouse when I was in college, and so we would load boxes and stuff, and every now and then we'd have to take stuff into the academic buildings, and so we'd roll a cart into the elevator, best we could, and we'd pack as much on the cart, of course, as we could, and there's always that weight limit, and there's an alarm that goes off if you exceed the weight limit. We would also, when there wasn't cartloads of stuff being loaded on the elevators, people would try to cram as many of themselves as they could into elevators. Well, these guys want as many boxes as they can safely put on the carts. They don't have to make as many trips. If the weight limit, if the maximum load is 4,500 pounds, then that means that whatever is on the elevator, the load has to be, Brecken, does it have to be 4,500? I mean, it could be less than that, but it could equal that as well. So we would say, right, the load has to be less than or equal to 4,500 pounds. So let's talk a little bit about the load. What all is involved in the load on the elevator? Well, first of all, Maddie, we have the 2 workers. So they weigh, how would I show 170 and 185? Right, so there's 170-pound worker, there's a 185-pound worker. There's also, class, their cart on whence they put the boxes. The cart itself weighs another 90 pounds, and in addition, they've got a whole bunch of boxes. We don't know how many. We'll call the number of boxes, class, X. But every box weighs 50 pounds. How would I show an unknown number of boxes weighing 50 pounds each, Brecken? So if we add the 50-pound boxes of unknown quantity, plus the cart, plus the worker, plus the other worker, that all has to stay less than or equal to 4,500 pounds. Did we get this inequality? Or perhaps we already combined when we started? Excellent. What do we get when we combine the 170, the 185, and the 90 all together? Brecken? Maddie? Good. Should combine to get 445 plus 50x is less than or equal to 4,500. Picking up from here then, Brecken, what should we do?
Attention teachers, when you are called down for pictures, please line up the kids tallest to shortest. Thank you.
Now we know why Noah skipped today. I'm just picking on, you know. All right. He's like, I do not want to stand downwind from Maddie. It's not fair. One day, Noah, one day, you may grow taller than Maddie, and then you'll feel good. All right. And then she'll start wearing high heels just to tick you off. Because that's the kind of person she is. Anyway, Brecken, back to you. What do we do next? And then, of course, go to this a 50x less than or equal to... Yeah, 4,055. All right, and then we have to divide both sides by the 50. And that's going to be less than or equal, let's see here, 4,055 divided by 50. Let's see, how many times does 5 go into 40, class? 8. So we're going to put the 8 here. 8 times the 50 is going to come to an even 400, leaving us with 5. Bring down the next 5. 50 goes into 55, class. Once, with another 5 left over. And we could say 5/50ths or 1/10. So it has to be less than or equal to 81 1/10 boxes. Well, again, a tenth of a box, nah. And since it says less than, class, we have to round down, which we would have anyway if we had to choose, but we don't get to choose. If it had been a greater than, we'd say 82. Since it says less than, class, we'll say at least, or no more than, 81 boxes. Is that what you had? All right, questions on number 10. Brecken, you said you didn't get it. Questions. All right, number 11, Brecken, read it for us.
Calvary's budget for a swing set and play fort to be built for the children's church is $900. If the cost of the swing set should be at least 1/4 as much as the fort, how much can be spent on the fort and still build the swing set?
All right, and the important thing is they are building it themselves. Because if you tried to buy something like what you see in the picture there, you're not getting that for $900, but you build it yourself, maybe you can. And so there's 2 unknowns here, right? 2 things that they want for this play area for the children's church. What are the 2 unknowns? The fort and the swing set. And so far, we've primarily been dealing with one unknown, one unknown. It's always X. Here there's 2. Which one gets to be X, Maddie? The fort, because it says that the swing set's going to be at least 1/4 as much as the fort. So the fort will be X, and the swing set is going to be at least 1/4. For our purposes, we will say 1/4 X, because we're going to tuck the at least somewhere else. Okay, so if the swing set costs 1/4 of the fort, swing set is 1/4 X, fort would be X. And together, the whole budget, class, is going to be $900. But the $900 is both fort and swing set together. And that's the budget. Would the church like to spend less than $900? You bet. Would they like to get it donated for free? Of course they would. Okay? So we would say not that the fort and swing set together must equal 900, but that it should be, class, less than or equal to. So fort plus swing set should be less than or equal to $900. Does that make sense? Did we have this inequality? All right, from here, we've got a couple options. We could go ahead and combine, or we could clear the fraction out. What did you do, Maddie? You multiplied everything by 4, and what was your equation then? There we go. We'll combine the x's together, Brecken. 5x has to be less than or equal to 3,600. We'll divide both sides by the 5. Do it with me, class. 5 goes into the 36. 7 times with 5 goes into 10 with nothing left, and 5 goes into 0, of course. So x, the fort, can be no more than 720. It cannot be more than 720. Less than or equal to 720. The swing set being 1/4 of that would be less than or equal to. Did it ask for that, or did it just say the fort? It just said the fort. So this is going into the limit. It would be 180. It didn't ask for that. And so you can make sure it adds up to less than or equal to 900. Questions on number 11? Go ahead and read number 15 now. We didn't do this one for homework, but this is similar to some things we've been working on recently. Brecken, read this one as well for us.
Tom and Lisa Byers have $16,000 to invest in two accounts, part at 8% and part at 10%. If they want to earn a return of at least $1,450 on the accounts, how much can they invest at 10%?
All right, I really want to know what sort of accounts are giving this kind of interest, but anyway. They're investing $16,000. They're like, we don't know what to do with it. Let's just invest in it. Anyway, must be nice. But, I'm not bitter, Lord takes care of my needs. I got no reason to complain. So two accounts, right? We have the 8% account, and we have the 10% account. And we don't know how much is invested in either account, right? But it just says part of the money goes into one, part of the other money goes into the other. How should I represent the principal, the amount of money that's invested in each? Maddie? Good. Which one do I recommend being X? The 10%. So we'll let the other one be the 16,000 minus X, total minus X. Of course, the rates, pretty straightforward, right? How should I represent my rates? Brecken? Good. Do I need to account for time in this problem, class? They have an oversight here. They didn't mention anything about time. Let's assume if they don't mention time, time has to be a year, because otherwise they would have had to mention it because it would have mattered. So we'll go ahead and ignore the time and say that P times R, ignore the T, is equal to the interest. How would I represent the interest earned on the 8% account, Brecken? And the amount of interest earned on the 10% account, Maddie? 0.10x. And the number we haven't used yet is the $1,450, right? That's how much money they want to make. Excuse me. They want to make at least $1,450. Do you see this is exactly like the other interest word problems we've been doing, except at the end it's not that interest plus interest equals a desired amount of interest, but interest plus interest needs to be at least a certain amount of interest. In other words, Brecken, at least meaning, so how will I write my, not equation, inequality? Not equals.
Greater than or equal to 1,450.
There we go. Really no harder, right? You just follow the steps, you do what we've been doing, you just put a greater than or equal to symbol when we get to the end. Of course, Maddie, I really hate decimals, so we need to, when I do, of course, this just becomes an 8, this just becomes a 10, and then this becomes, two more zeros, so 145,000. In other words, you move the comma back 2 places as well. Of course, now we need to distribute. This is the fun part. 8 times 16,000. Good. No, 128,000 is correct. All right. And then, of course, the 8 times negative x is negative 8x plus 10x is greater than or equal to 145,000. You don't want to be shown up by the guy on the other side of the camera. We need to combine our x's here. Maddie? 2x, and at the same time, let's move the 128,000 over as a negative 128,000 to get, yep, you got it again, 17,000, good, Noah. And then we need to divide both sides by the 2, and that'll give us x needs to be greater than or equal to, Gavin this time, 8,500. All right, which means the question was asked, how much needs to be invested in the 10% account? X was the 10% account. How much do they have to invest, class? Not 8,500, at least 8,500, greater than or equal to. the $8,500 or minimum $8,500 at that account if they want to earn that interest. Questions on this word problem? Special thanks to our absent students for helping us there. Questions on this? Questions on this? All right, look back at page 142. Yesterday I began talking about compound inequalities. And the difference, remember, between a compound inequality and a regular inequality, the compound inequality has not just one point and it goes to infinity, or one point it goes to negative infinity, or a whole and they both go to negative and positive infinity, right? But rather there's two ends to the graph. It's everything between these two values. We see there, remember, we talked about an open inequality. As you look at the bottom of page 142, where there's an open circle and an open circle on each end. A closed inequality, of course, would have filled-in closed dots on both ends, and a mixed inequality would have one of each. But pretty straightforward as far as graphing it. You put the dots or circles where you're supposed to and shade everything in between. So on your paper, if you would, go ahead and set up 3 number lines. I want you to graph 3 compound inequalities. I want you to graph 3 compound inequalities on your paper. -1 is less than x is less than or equal to 5. 2 is less than or equal to x is less than 7. -2 is less than x is less than 4. If you want to use graph paper for this, you may. Don't necessarily have to. On the first one, class, I need to find my first point, which is -1, and I need to put a circle. Then I need to go to my second point, which is 5, and I need to put a solid dot. And then I just shade everything in between. And there's my inequality. We have something like that for the first one. On the next one, bracket, I need to start by putting a, and what do I need to put at +2? A solid dot at +2. Then I need to put a, I need to shade everything in between. There we go. All right, and Maddie, on the last one, start by putting a, and there we go. Did we have graphs that looked just like these? All right, good. Now, last night I had you read over just a few pages on how to solve compound inequalities. I want to work a few of these with you based on what you read. So I want to start by looking at problem number 4 over on page 144. So turn the page, page 144, and look at number 4. It gives us the inequality 0 is less than 2x is less than 4. Now again, this is a compound inequality because we can see that there are 3 parts. There's the unknown value in the middle, and there are, of course, quantities on the outsides. Now, you remember when solving an equation or earlier inequalities, we said that we want to get the x by itself, ultimately, right? How would I get the x by itself here, class? Good, divide away the 2. Not a trick question, just really straightforward. And of course, that gives me an x. And I've always told you what you do to one side, class, you got to do to the other. That assumes there's 2 sides. I don't have 2 sides. I have 3 pieces or parts, don't I? So what you do to one thing, you got to do to everything, meaning this piece, this piece, this piece. So I have to divide these by 2 as well. And so that'll give me here, class, a 0 is less than x is less than 2. Do you see that it's really no different than anything else we've been doing? You just have to do it 3 places now instead of 2. Look at number 6 with me. I've got a negative 3 is less than x minus 1 is less than 0. Again, the key is to get the x by itself. What do I have to do to get the x by itself this time, Brecken? And if I add 1 here, I also have to add 1 everywhere. Now notice, this kind of knocks out the whole move it over, right? Because I can't move it over singular, because I can only move one thing one place. So here it's better to think of the, go ahead and add 1 to everything. That gets the x by itself, and we're going to get here, class, that negative 2 is less than x is less than 1. Questions at all? Did you get that from your reading? As you were doing the reading, did you get, okay, this is what they want us to do? So you already should have known going in what we were looking at. Let's take a look at number 8. We've got negative 1 is less than 2x minus 1 is less than 3. Maddie, this time I've got to do 2 things. First, I need to add 1. Where do I add 1? Everywhere. Add 1 here, add 1 there, add 1 there. Now, again, this is all one thing. So I'm not adding 1 to this and to that, just to this middle piece. And of course, that'll allow the 1s to drop out, giving me, Maddie. And suddenly it looks an awful lot like what we did back there, right? Our next step is to divide away the 2 from every part, and that'll give us our answer like we got before. And would this be an open, closed, or mixed inequality? When I graph it, would I use open dots, closed dots, or one of each? I'd use open dots, and we call it an open inequality, an open compound inequality. Let's take a look at number 10. And here we've got a negative 4 is less than or equal to 2 times x negative 2 is less than or equal to 6. Now, Brecken, here, before I can start worrying about getting the x by itself, I really need to do what first? Good, I need to distribute the 2. Now, I will throw this thought out there. I could divide this 2 from everything, couldn't I? That'd be an option. But conventionally, what we would normally do, we see parentheses, we distribute. To get negative 4 is less than or equal to is less than or equal to 6. Now again, in times past, we said, hey, there's a negative 4 on both sides, cancel them. But it's not both sides, there's 3 places. So really, instead of canceling, what do I need to do in every spot? Add 4. And it'll have the effect of canceling here and here, but obviously not here, giving me what new inequality now, Brecken? And then finally, we need to finish by simply dividing away the to get. What kind of compound inequality is this, Maddie? It's not mixed because they don't have one of each. It's closed. They would both have closed dots at the end, the 0 and 5 both included. Questions on this? Very quickly, do number 3 through number 9 there on page 144. In the practice section there, 3 through 9, the practice on page 144. Shouldn't take you real long. and Brecken's finished. All right, let's go and take a look at these. Number 3, what did you get for your answer, Brecken?
-2 is less than x, which is less than 3.
Good. -2 is less than x, which is less than 3. Number 5, Maddie. Good. 2 is less than x, which is less than 3. Number 7, what did you get, Brecken?
0 is less than 6, which is less than 3.
Oh, x. 0 is less than x, which is less than 3. At first I was like, that doesn't sound like it can't be right. That's got to be an x. All right, and then number 9, I had a little distribution to do and some addition and then some division. What did you wind up with here, Maddie? Good. -1/2 less than or equal to x, less than or equal to 2. Did we get all 4 of those correct? Excellent. Why don't you take a look at number 12 with me now. Go and write it down on your paper. 4 is less than -x is less than 7. Now here, very straightforward, in order to get rid of to get the x by itself, the negative is the only thing that has to go, right? So I just have to divide everything by a -1, correct? Or in other words, change all the signs. When I do, my 4 class becomes a -4. My -x becomes +x, and my 7 becomes -7. However, anytime you multiply or divide by a negative class, you have to flip the inequality. Including in a compound inequality, my less thans class both must become greater thans. The problem with this is if you look at the number line class, is -4 here and then -7 here, for instance, where we could shade everything in between. Is that what the number line looks like? No, that's backwards. -4 would be on this side of things. This is a wrong way to leave the inequality. It's backward looking. So what we have to then do is imagine yourself on the other side of the chalkboard looking at it this way. In other words, flip the whole thing around. The -7 is going to flip around here. The point is going to continue aiming at the -7. The mouth is going to continue opening to the x, but this point is going to aim at the x. This mouth is going to open to the -4. Do you see all we did was flip the entire thing around again so that it now looks correct. That's only going to happen with a compound inequality when you have to divide a negative. But if you divide a negative, you are going to have to flip that inequality. Does that make sense? So let's take a look now at number 14. Write this one down with me. 3 is less than -x minus 2 is less than 7. First step, very straightforward, Maddie. Add 2 to everything. And that's going to give us and now, what am I going to have to do, Brecken? Which initially, and don't skip this step, initially is going to give me what? Correct answer incorrectly written. Oh, flip it around. Right, now we're going to flip the entire thing around. When I do, the first thing I should write, class, is going to be -9. Then this greater than is going to flip back and become the x can't really flip. This greater than symbol now flips to become a less than, and then finally the -5 winds up over here. Now the reason I point out the whole thing flipping is because if this had been a greater than or equal to, then this would become the less than or equal to. Because this is the sign that's with the -9, so when it flips back around, it's not that I'm flipping this sign and this sign, no. That sign comes here. So number, sign, value, sign, number. Everything flips its location. Does that make sense? All right, let's take a look at number 16. Number 16. 0 less than 2 -x less than 5. And Brecken, start us off this time. To get? All right, Maddie, now we need to divide everything by the -1 to get. Ooh, careful. Ooh, we're dividing by a negative. Good. Now, Brecken, let's move the entire thing around. What do we get? There we go. Does that make sense? That dividing by a negative thing just makes it a little complicated because when you flip the inequality signs, the whole thing now looks backwards. We just have to correct it back around again. Number 18, negative 3 less than negative 4x positive 1 less than 9. And let's see here. Maddie, start us off. All right, now Brecken. To get? And then Maddie, let's flip the whole thing around to get. There we go, because the point still aims at the x and the mouth still opens to the 1. And there we go. Do you feel like we're getting the hang of this one? All right, number 20 kind of changes gears off the whole negative concept. I see a fraction. I've always hated fractions, and I'm not one given to change, so I still hate fractions. Even if it's in a compound inequality, I hate fractions. So what do you think I'm going to do, class? Thank you, Brecken. And Gavin and Noah, if you were answering. Basically everybody but Maddie. Maddie, we multiply everything by the LCD, which is, of course, so multiply everything by 2 to get what? Super easy, right? Don't make it hard. Okay? No negative to have to worry about there at least. That's got to be a nice feature. Look at number 22. Copy this one down. We've got a negative 2 less than or equal to x negative 3 over 4 less than or equal to 1. This time, Brecken, we're going to start by multiplying everything by 4 to get. Good. Because the 4's cancel cleanly to leave me with the x negative 3. All right then, Maddie. Good. Add the 3 everywhere to get. And we're done. Questions on what to do with fractions? We've got a good handle on fractions. All right, do number 24 at your seats. Number 24 at your seats. Multiply the 4, then subtract the 1, then divide the 3. So 3 steps. And Brecken, you got it? Maybe. All right, Maddie has more confidence. Maddie, what did you get? Good. Negative 3 is less than or equal to x, which is less than or equal to 5. Did you get that, Brecken? You think so? You can't read your own writing?
I can read it. I just don't know what I did.
All right, let's take a look at it real quick, Brandon. Hopefully you multiplied everything by 4 to get negative 8 less than or equal to 3x plus 1 is less than or equal to 16. Did you do that? No, you didn't do that. Do you see that you should have did that?
I just didn't get the 16.
You got a 4 still.
I put 8.
Oh, 4 times 4 is...
16.
Yeah, should have been multiplied by that 4 there. Okay, all right. I wanted you to consider something for a moment. It's been a little while since we talked about these absolute value equations. And you remember when we talked about absolute value equations, we said, number one, get the absolute value by itself, such as we see here. Once you've done that, we said, well, realize that what is inside technically could be either positive 4 or negative 4. Because when you take the absolute value of 4 or negative 4, you get 4, right? So we said to solve it, we're going to take whatever's inside and say, well, that's equal to 4, or it's equal to negative 4. And we would solve from there, right? But what if instead of an equal sign, what if it said greater than, or less than, or greater than or equal to, or less than or equal to? In other words, what do we do with an absolute value inequality? Next section in your notes. Absolute value inequalities. Absolute value inequalities. We're going to start with a very basic one. Consider for a moment this, write this in your notes if you would. The absolute value of x is less than 5. Well, let's think about what numbers you could take the absolute value of and get something smaller than 5. Well, the absolute value of 4 would be smaller, right? Also class the absolute value of 3, 2, 1, 0. Negative 1, yeah, absolute value of negative 1 is 1, that's smaller than 5. Negative 2, negative 3, negative 4. Ooh, wait, the absolute value of negative 5 would be 5. Is 5 less than 5? No, so we realize if we took the absolute value of any of these, even negative 4.99 technically, right? Even like 4.9. But basically anything in this group of values, the absolute value would be less than 5. So we could say that if we were looking at this on a number line, we would find positive 5, we would find negative 5, not including 5 or negative 5, but right up to it, right? And anything in between the positive and the negative would satisfy. Remember, absolute value, we always said set equal to positive, negative. Here we set in between positive, negative. So we would say that x is greater than negative 5, but less than positive 5. We would get a compound inequality. Get this on your paper if you would, please. But think about this though. What if I'd said the absolute value of x was greater than 5? Well, what's a number that if I took its absolute value would be greater than 5? 6, 7, 8, all the way up to infinity, right? What about negative values? Well, negative 5, the absolute value is 5, which isn't greater than 5. Okay, how about, speaking integers, negative 6, negative 7, negative 8, really all the way to negative infinity, right? If we were to look at a graph from 5, not 5, but anything bigger than 5, absolute value would work, and then anything smaller than negative 5, all these values would work, right? So notice here, it's not equal to positive and negative 5, it's everything above the 5 and everything below the negative 5. Do we see that? So x is smaller than negative 5, or x is bigger than positive 5. Still, absolute value always has the idea of positive, negative. Before it was equal to positive, negative. Sometimes it's in between positive, negative. Sometimes it's outside the positive, negative. But the bottom line is positive, negative is still key. It's just, is it equal to positive, negative, between the positive, negative, or outside the positive, negative? Here's a couple of rules I want you to write down. A couple of rules I want you to write down. So that was to get us to think. Here's the boring rules to memorize. The absolute value of x, if the absolute value of x rather is greater than a, then our value is going to be that x is going to be less than negative a, or x is going to be greater than positive a. If the absolute value of x is greater than a, x is going to be less than negative a, or x is going to be greater than a. In other words, x is going to be outside the positive negatives. if the absolute value of x is less than a, then x is going to fall in between negative a and a. That is to say, it's going to fall between the positive negative. So we're still thinking positive negative. Every single time we have an absolute value, something. Absolute value equation equals positive negative. Absolute value inequality, okay, wait a second. Is it between or is it outside? But the positive negative is still the key points, if you will. They're still where you'd put the dots on the number line. It's just, are they open or are they closed? Now we have to ask that question. Here, they'd be closed, right? If it had the or equal to. Without the or equal to, it's circles, right? So that's one thing. And then, are we in between or are we outside? Here's a good way to think of it. That which is big can't fit inside. That which is big has to stay outside. If you have a big dog, and if you have a big dog, and mom's like, no, that dog is not coming in the house. He can sleep outside. Okay? Unless your mom's a real softie. Or does the dog sleep outside?
The dog is spoiled.
The dog is spoiled. All right. My dad grew up like with the German Shepherd, Siberian Husky. Those are like his favorite dogs. And outside. Always outside. They fine out there. They can take care of themselves. Okay? We'll feed them. We'll bathe them. The things outside. The little doggy. The little pet poodle. Anyway, little tiny doggy, that can fit inside just fine. Little, smaller than, fits in between. It fits inside the positive negative. So let's go back for a moment then to that 3x plus 2. Remember we said equals 4? Let's say less than or equal to 4. We still have an isolated absolute value. That's what we need, right? We want an isolated absolute value, just like before with equations. Equation and inequality, we solve them pretty much the same way. However, because it's not equal to, I don't set it equal to positive negative 4. Class, I'm going to set it less than means I'm going to go where? Inside or outside? Inside. What I recommend my students do is draw a very quick sketch graph of the positive negative 4. And either put the 3x plus 2's outside, which is wrong in this case because it's less than, or put it inside. Allow yourself to visibly see the range of values. Does that make sense? Once you can see it, then writing negative 4 is less than or equal to. 3x plus 2 is less than or equal to 4. Seems really easy. And now we just have to solve. Let's start class 5. Subtracting the 2 everywhere to get is less than or equal to 3x is less than or equal to 2. And then divide everything by the 3. And so, for our solution, we'll get that negative 2 is less than or equal to x is less than or equal to 2/3. But, stay with me, if we said the absolute value of 3x plus 2 is greater than 4, well, I still am thinking absolute value. I've got to think, class, positive negative. But instead of equal to positive negative 4, or even between positive negative 4, it's too big. It's greater than, class. I've got to leave it outside. So my 3x plus 2 is here, and my 3x plus 2 is here. It's everything out here and everything out here, technically with circles this time. So to write this inequality, I've got two separate inequalities. I've got that 3x plus 2 class is less than negative 4, or I've got that 3x plus 2 is greater than 4. And now, in each case, we have to start by getting rid of the 2 by subtracting the 2. And that'll give me that 3x is less than negative 6, and that 3x is greater than 2. And then divide both sides by 3 to get x is less than negative 2, or x is greater than 2/3. Notice it's the same values, 2/3 and negative 2. It's just in between versus outside. And if it had been an equation, I would have gotten equals negative 2 and 2/3. So it's very similar with the positive negative thing. It's just a matter of, do I put it inside or outside? Like the song 2 points, no, the 2. You know, inside or outside, which side are you? You know that song you learned in Sunday school? Yeah, you didn't. She did. You know the song I'm talking about. Anyway, inside less than, outside greater than. That's what we're going to be working on tomorrow. Your homework for this evening is to read over pages 145 to 147. I want you to read over some examples of these absolute value inequalities. Read pages 145 to 147. On page 144, do the practice. 11 through 23 odd. Page 144, do the practice, 11 through 23 odd. Also on page 144, do the review 2, 4, 5 through 10. Page 144, the review 2, 4, 5 through 10. We have our exam coming up on Friday. That's lesson 134. This is the final concept we're going to discuss is absolute value inequalities. We're going to wrap that up tomorrow, begin reviewing, and then, of course, Thursday is all review. But lesson 134 is your exam. Covers chapters 3, 4, and 11. 3, 4, and 11. All right, have a wonderful rest of your day. You are dismissed.